Hello, can you hear me? Right. So we'll continue with the problems that we saw yesterday. Problem 41, has everyone gotten?
Yes, sir.
Are you getting x is equal to 1 here?
Yes, sir.
Okay, that is the answer. The solution is not very difficult. You have to cube both sides and make it into an equation. And you have to notice the pattern. Finally, you will get something like this. 15x squared minus 2 by x whole cube is equal to 13 cube. This equation you will get, and then it will become a cubic like this. 15x cubed minus 13x minus 2 is equal to 0. And in this cubic, it is easy to see that 1 is a root, right? So you can factorize it as x minus 1, 15x squared plus 15x plus 2 equals to 0. And this has no real roots, whereas this has root, which is x is equal to 1. So those are the key steps involved in this question. We will not spend too much time on it. What about problem 42, which was the geometry one? We had quadrilateral ABCD is inscribed in a circle of area 2017 pi. And what was given was AB is equal to 18, BC is equal to 88, CD is equal to 89, and you have to find DA. Has anybody gotten the answer for this? Question 42 and 43. 43 was the trigonometry one. If you have not solved it yet, you need to try it right now. Try this question right now. Can everyone hear me?
Yes, sir.
So try this question right now, 42 and 43. 43, hopefully you have written down also yesterday, right? You have 5 minutes, at least for this problem. Take 5 minutes, attempt it. I'll be back in 5 minutes. I'll put myself on mute. Try it yourself.
Sir, actually, I had a lag, so I wasn't able to speak. Sir, wasn't able to do this question. I had a doubt in this.
What are you saying?
Actually, I had a lag, so I wasn't able to unmute myself. I wasn't able to do this question previously.
So you have 5 minutes to try it right now. I will discuss the solution after 5 minutes. I'll be back. Okay. Try it right now. Okay. Anyone getting anything?
Sir, I've got an approach.
Okay. What? Tell me.
Sir, basically we first find the radius of the circle and it is coming out to be under root 2070. And then we assume the center and join all of the vertices to the center.
Mm-hmm.
Uh, then we can calculate the individual areas and equate it to the total area of the quadrilateral using the Gupta's formula और उससे हमें एक इक्वेशन मिल जाएगा उसे सॉल्व कर देंगे.
What have you gotten so far?
अभी तो सर कैलकुलेट कर रहा हूँ इंडिविजुअल ट्रायंगल्स का एरिया कैलकुलेट कर रहा हूँ जो फॉर्म में.
It is going to take a lot of time by the approach that you are taking, right? Think of a better approach which will do it in a small amount of time, right?
ओके सर.
Okay, my labeling is wrong. I should label it C and D. So C and D. So what you can do is, you know that all of these are equal. And this is R, right? Capital R. The radius of the circle, right? And we know BC is 88. And we know CD is 89. And we know AB is 18. Okay. So if you think of triangle OBC, in triangle OBC, what is cos of OBC? OBC. If you think of the cos of that angle, that would be equal to R square plus 88 square minus R square divided by, do you understand what I am doing? Cosine rule divided by 2 into R into 88, right? So clearly this is becoming cos of OBC is equal to 88 by 2R. Basically 44 by R. And radius of the circle is known because pi R square is 2017 pi. So radius is square root of 2017. So we are getting cos of OBC is equal to 44 by square root of 2017. Great. And in triangle OAB, we can do the same thing and find cos of OBA. OBA. If you do that calculation, you will get 18 by 2R now. By cosine rule, you will get 9 by root over 2017 is cos of OBA. I hope it is clear what we are doing so far. These two angles, cosines we have found. Then we can even find the sine of OBC and sine of OBA. Sine OBC is coming out to be 1 minus 44 square by 2017. You will realize that that is 81 by 2017. So that is basically 2017 minus 44 square. So yeah, it will be at 9 by square root of 2017, right? And similarly, cos of sine of OBA. Let's find sine of OBA. In that case, you will get 44 by square root of 2017. Because we are finding it from this cosine value. And now you can easily show that the angle here, these two angles are adding up to 90 degree. Because we can see that they are complementary in nature. Another way to show that is by saying find cos of CBA is equal to cos of OBC plus OBA. That is equal to cos OBC cos OBA minus sin OBC sin OBA. And now you can check the values. Cos OBC is 44 by this. Cos OBA is 9 by this. So you're getting 44 into 9 by 2017 minus sin OBC and sin OBA also is 44 into 9 by 2017. So this is equal to 0, which means angle CBA is 90. CBA is 90, which means AC is the diameter. And this is a right angle triangle. Right? And if this angle is 90, then this angle is also 90. And if this angle is 90, we can do Pythagoras theorem and say 89 square plus x square should be equal to AC square, which is the diameter. So we get 89 square plus x square is equal to diameter square, so 4r square. And r was root of 2017, so 4 into 2017. You're getting x square is equal to 8068 minus 89 square. Calculate this, you will get 147. X is equal to root 147. That is the fourth side. I hope everyone is understanding what we did. We got the angles, one particular angle we focused on, angle OBC and OBA, we got by cosine rule, cos of those. If you know the cos values, you also know the sine values. So the overall angle is the sum of cos OBC plus OBA. And we got that overall angle ABC is coming out to be 90 degree, which means AC is the diameter and then AD is very easy to find. I hope it is clear to everyone.
Yes, sir.
It is an application of cosine rule. It's not very difficult. And this trigonometric result. Let's go to problem 43.
So
Hmm.
for the previous problem, I have a different approach, sir.
Okay,
Can you
what is
say
the
whether
approach?
Sir, actually, all those four are isosceles triangles, right, sir?
Hmm.
We are finding using cos rule, we are finding some value for the equal angles, no, sir.
Mm-hmm.
With that, we can calculate this angle subtended by it at the center of the circle, no, sir.
Right.
So adding up all the cos inverse or some inverse trigonometric functions and equal to 2 pi, with which we will find the angle
Like, see,
d by n, sir.
you have, what do you have here? Like what I'm doing is I'm getting the cost value here and you're getting a cost value here also. What are you doing?
Now I'm finding the angle subtended by each side on the that angle, sir.
It is almost the same thing. Like You will show that this will be an 180-degree total, right?
No, sir, I am not considering this to be special case wherein a right angle forms. I'm considering it to be a general case, sir.
But the general case, if you do, then you will not get anything, no, here, because in general, it is not necessary that right angle will be formed.
So sir, so that only I'm considering that it does not form right angle triangle and proceeding differently, sir.
You can do it, but the point is, in this question, you have data given, no?
Sir, okay, sir. With the data, I'm finding the angles subtended by each known sides at the center, sir. With which I will find the unknown angle, and I'm having the value for R also, sir. So
Right,
R,
you can do it like that, but it is technically you will get again 180 and stuff. No, it will be the same thing finally. Like you will say 2 pi minus this and this and this.
yes, sir.
So,
If you
but
are
this finding this itself will,
R sin theta by 2 will be my R
right.
PAD.
But you can try it out and do it as long as you get the answer in a reasonable amount of time, right?
It's quite complicated with the inverse trigonometric functions and also.
Yeah, so that's why you should not do it like that, because you will have to add inverses of 3 inverses. No,
Yes, sir.
it's not a nice way to do it.
Okay.
It is possible to do it, but it will be annoying to do. No,
Okay, sir. I just wanted to check the correctness of it.
it is correct, but it will take some time to do, right?
Okay.
There is no issue with the idea, but it will take more time, right? Okay. The 43rd one was let A belongs to 0 to pi, and we were given 1 by 3 sine A minus 1 by 7 cos A is equal to 1 by 2017. And then the question was, what if tan A modulus is m by n, where m and n are relatively prime positive integers, you have to find m plus n. Basically, you have to find the value of tan A from this equation. A little bit of simplification, if you do, you get 7 sine A minus 3 cos A is equal to 21 by 2017. Now, how to find tan A from this side, this type of an equation?
Sir, I did like I turned it into like I multiplied it and divided by under root 58.
Okay.
So I simplified it. So sine A minus sine inverse
You will
3.
get something like this then, right?
Yes, sir.
You will get something like this and root 58 and all, right?
Yes, sir.
But that doesn't help you so much because there is an inverse function here, phi also, right?
Sir, I also thought of another method like divided by cos A, like both side. And then like the sec A can be turned into under root 1 minus 10 square A.
Sec A will become under root 1 plus tan square A.
Yes, sir, sorry. And
Uh,
it will be a quadratic, so we can solve it. But I didn't try it. The method I didn't try.
सर
uh,
सर
क्या
आई आल्सो हैव एन अप्रोच, मतलब मैंने उसे ट्राई नहीं किया बट शायद वो वर्क करेगा
क्या
कि cos A को कॉमन ले लेते हैं और उसे RHS में भेज देते हैं सीकेंट बना के, फिर
that's
दोनों
the
साइड।
same approach that Aradhya just said, no?
अच्छा
Cos A डिवाइड करके sec A को रूट ओवर 1 plus tan square A करोगे, right?
हाँ
तो वो तो सेम ही है, अभी तो वही बोल रही थी. But that way is also going to be a little problematic because of the square roots and all.
Will be tedious.
It will be a little annoying to do it like that. The standard way to do it, if I have a situation like this is something that you will learn in calculus later. if you do a little more calculus, you will realize that there is a standard substitution in such situations, which is tan a by 2 is t. Why tan of half angle? Because both the sine and the cos can be written in terms of this. So
Yes.
sine A can be written as 2t by 1 plus t square, and cos A can be written as 1 minus t square by 1 plus t square. You can check these identities. These are easy to prove. If you take half of tan A by 2 as t, this is what you'll get, right? In that case, the equation starts looking like this: 14t by 1 plus t square minus 3 times 1 minus t square by 1 plus t square is equal to 21 by 2017. This is our equation. It's a quadratic equation. You have to take 1 plus t square on the other side, bring 2017 on one side. It's a simple quadratic equation. If you simplify it a little bit, you will get something like 2017 times 14 t minus 6051 plus 6051 t square is equal to 21 plus 21 t square, right? So basically, bringing everything on one side, you get 6030 t square plus 2017 times 14 t and minus 6072 is 0. You can divide by 2 here. You will get 3015 t square plus 2017 times 7 will become 14,119 t minus 3036 is 0. This is obviously a horrible equation, but there is a solution. You will get minus 14,119 plus minus. Wait, I have made a mistake in the sign, I think. No, I think I have made it correct only. Yeah, the sign is correct for the t term, right? Yeah. Plus minus root over 14,119 square minus minus, so plus. Okay, this will be a really bad. Something like this is coming for us. What you need to realize here is we cannot take a negative root. Why? Because a was belonging to 0 to pi. So a by 2 is also in this range, and then tan a by 2 has to be positive. So immediately I can reject the negative sign here. And now you have to calculate this. You should use a calculator in this case because it is super big. If you calculate it, you should get 44 by 9. It will eventually cancel it out to be this. And if t is equal to 44 by 9, then what is tan a? How do we find tan a? If tan a by 2 value is known, tan a will be 2t by 1 minus t square. I hope everybody is clear on this. So you will get 2 into 44 by 9 by 1 minus 1936 by 81. So you're getting tan a value to be 81 minus 1936 would become 1855. And this goes on top, it becomes 81 times this. So 44 into 18, that is 792 with a negative sign and 1855 here. So tan A for us is coming out to be minus 792 by 1855. You have to see if there is any common factors, and then you can find m plus n. M plus n has to be calculated after taking the modulus. So the equation turns out to be horrible, but the idea is important to know. If you have a linear function a sin x plus b cos x is equal to c, finding tan x from here, the best way to do it is by taking tan x by 2 as t. Is everyone following what we have done? You will be able to convert this into a simple quadratic by saying a into 2t by 1 plus t square plus b into 1 minus t square by 1 plus t square is equal to c. And this becomes a quadratic in tan x by 2. So that idea is important for everyone to learn. I hope it is clear to everyone. Okay, we'll go
Yes.
on to the next one. The question is this. In Euclidean space, consider a sphere of radius square root of 2018 centered at the origin. Let P, if P is a point in 3D space 512, A and Q 916, B, B points on the sphere. B points on the sphere. A and B are positive. Find PQ, the distance between the points P and Q.
Sir, A square is 1849, B square is 1681.
You have to find PQ distance.
Okay. Okay.
You don't have to find A square and B square. It's a very easy question.
Sir, 6.
P and Q lie on the sphere. So obviously, if the center of the sphere is the origin, OP square,
The answer. 6.
OP square is equal to this is equal to OQ square is equal to 9 square plus 16 square plus B square should be 2018. And from here you will find A square and B square. And technically what you have to find is PQ square is 5 minus 9 square plus 12 minus 16 square plus A minus B whole square. You have to find this quantity. It is easy to find that it is 6. I hope it is clear for everyone. This is not very difficult, right? Let's move on to the next problem. This one is let ABC be real numbers such that 3A plus 28B plus 35C times 20A plus 23B plus 33C is equal to 1. Find or not find, prove that A square plus B square plus C square is greater than 1 by 2018. We have done a problem like this before. So if you recall what we learned in that problem, you will be able to solve it. Think about inequalities, what inequalities we saw before. You have to apply Cauchy's inequality. Does everyone know what Cauchy's inequality is?
Yes, sir.
So try to apply it. Try to see how to apply this in this question. If someone doesn't know Cauchy's inequality, tell me.
Sir, I don't know.
Have you learned about vectors, basic vectors and all?
Yes, sir.
Yes, sir.
So if you think of a vector, A vector, you know that it can be split into the components, right? I, j, k.
Yes, sir.
X1i, let's say x2j plus x3k. This is A vector. Let's take another vector, B vector. That is, let's call it y. y1i plus y2j plus y3k. Now, if you have learned vectors, you know that the modulus of this vector is the length of the vector is this, right?
Square of sums. Sum of squares.
And the mod of B vector would be root over y1 square plus y2 square plus y3 square, right? Correct?
Yes, sir.
And the dot product of the vectors A dot B is defined as AB cos theta, right?
Yes, sir.
And the dot product, if the components are known, the dot product can be calculated by a direct computation, right?
X1, Y1 plus X2, Y2.
X2, Y2 plus X3, Y3. So dot product, we know computation, we know X1, Y1 plus X2, Y2 plus X3, Y3 is equal to A and B mods are these, right?
Yes.
Square root and square root, two of them, right? Correct?
Yes, sir.
So can you see here that this is equal to this into cos theta, right?
Yes, sir.
And we know that the cos theta mod is always less than equal to 1, right?
Yes, sir.
So what we can say is that the product of square roots should be greater than equal to x1 y1 plus x2 y2 plus x3 y3, right?
Oh,
Product
yes,
of
sir.
these two must be bigger than this, no? Then only when you multiply with a cos, it becomes equal, right?
Yes.
So if you square this, because cos theta is less than equal to 1. So now, if you square both sides, there, what we get is the inequality that x1 square plus x2 square plus x3 square times y1 square plus y2 square plus y3 square is greater than equal to x1 y1 plus x2 y2 plus x3 y3 whole square, which is another way of saying that a square b square is greater than equal to a dot b square, which is obvious, right? If you think of vectors, this is obvious. Is it clear right now what I have done?
Okay, sir.
This inequality is known as Cauchy's inequality. It can be extended to vectors of more than 3 dimensions also. It can also be lowered to 2-dimensional vectors. We can say x1 square plus x2 square times y1 square plus y2 square will be greater than equal to x1 y1 plus x2 y2 whole square. Right?
Okay.
Do you understand what the inequality is? How
Yes,
it
sir,
comes?
but can X1, can this inequality be applied for any set of numbers or only in vector form?
X1, x2, x3 are real numbers, any real numbers. This inequality is valid for all reals.
So there is no need that x1, x2, x3 and y1, y2, y3 should be part of the vector.
No, that is just I am giving you a proof so that you can understand. There is no need to
Okay,
use vectors to prove it.
okay, sir.
The proof I have shown is the proof that you will understand. Otherwise, you don't need to do it by vectors.
Okay, sir.
The inequality is valid in general. I have shown you a proof so that you understand easily why it is happening. Is it clear?
Yes, sir.
For any reals, it is true. The equality happens when x1 and y1 are proportional. When the two vectors are parallel, then you will get equality because then cos theta will be 1. Do you understand what I'm saying?
Yes, sir.
Suppose two vectors were parallel, angle between them is 0, then cos theta will be 1, right?
Yes, sir.
In that case, that though both sides will be equal, no, this will be equal to this, right? Correct?
Yes, sir.
So the equality case happens when the two vectors are parallel. And if you know the components are x1, x2, x3, y1, y2, y3, parallel means x1 by y1 should be equal to x2 by y2 should be equal to x3 by y3. The ratio of the vectors components must match for the vectors to be parallel. Again, I am explaining using vectors doesn't mean you need to do it by vectors.
Okay, sir.
This is the equality condition for the Cauchy's inequality. If all these three ratios are same, then both sides are equal, not greater, right?
Okay.
Is it clear to everyone what we have just discussed?
Yes, sir.
So now, how do you apply this inequality in this problem?
सर ABC को स्प्लिट अलग से कर देंगे और 328 और 35 को अलग से कर देंगे तो एक सेट बन जाएगा और वैसे ही
Right.
23 और 33 को अलग से स्क्वायर करके ऐड करेंगे और a
Hmm.
स्क्वायर b स्क्वायर c स्क्वायर को अलग से.
Correct. So basically, we'll do it two times. We will say 3a plus 28b plus 35c is like my dot product, right? So I will say I have two vectors 3i plus 28j plus 35c and another vector ai plus bj plus ck. Oh, this is k. And the dot product of this is 3a plus 28b plus 35c. And by the inequality we have just now seen, this square should be less than or equal to the individual mods of these vectors, right? 3 square plus 28 square plus 35 square times a square plus b square plus c square. I hope it is clear to you, Vinay.
Yes, sir.
Similarly, you can say 20a plus 23b plus 33c square should be less than equal to 20 square plus 23 square plus 33 square multiplied by a square plus b square plus c square, right?
Yes.
Correct.
Yes,
So
sir.
now you have two inequalities. This is 1, this is 2. If you multiply both the inequalities, the left hand side with the left hand side, right hand side with the right hand side. When you see do the left hand side multiplication, you will realize that that is 1 according to the problem, right? According to the problem, we had this product is 1, no? So the square of that is also 1, right? I hope that is clear to everyone. Is everyone understanding what I'm saying?
Yes, sir.
I'm multiplying these left hand sides and these right hand sides. I will get 1 is less than equal to the product of 20 square plus 23 square plus 33 square multiplied with 3 square plus 28 square plus 35 square and multiplied with a square plus b square plus c square whole square. Right? And when you calculate this, this is coming to be 2018 and this is also coming to be 2018. You can check that. You eventually get 1 is less than 2018 square, 80 a square plus b square plus c square whole square. And then it is obvious that a square plus b square plus c square is greater than this. You take this on the denominator and remove the squares. I hope it is clear what we have done. Does anybody have a doubt? Okay.
No,
Uh,
sir.
Fine. So that is problem 45. And learn how to apply Cauchy's inequality. Go to the internet, see some examples. You need to be very comfortable with Cauchy's and AMGM for sure. These two are definitely absolutely important. There are some more which are important, which I have covered in my algebra course, by the way. You can check it out.
सर कौन सी नाम बता दो.
ऑलरेडी नाम तो है बहुत सारे का है.
जो अभी फर्स्ट स्टेज के लिए इम्पोर्टेंट.
फर्स्ट स्टेज के लिए AMGM and Cauchy is enough. Of second stage onwards, you will need some more inequalities, but rearrangement you will need. You will need the extension of AMGM. AMGM extensions भी हैं. AMGM, HM, QM, all of this, which is also sometimes called power mean. Rearrangement inequality is super important. There are some others that might be relevant, but only at the INMO level and all. At the IOQM and RMO level, you need to know these two. And if you can do these two, then it is fine. You don't need to know anything more. Okay, that's all for now. I will continue in the next session. Most likely we'll do a class tomorrow. If not, I will mention on my channel. If there is no class, I'll let you know. Okay, that's all for now. I'll see you tomorrow then.